helium was recognized first in the sun and resisted by chemists and physicists. More recently, a very serious one, the sun and stars and quasars and all the rest, nearly all the atoms are hydrogen, and almost all the remaining ones are helium. This was first demonstrated in a 1925 PhD dissertation at Harvard. The writer of the dissertation was Cecilia Helena Payne, later Payne-Gaposchkin. Nobody took this seriously. She also showed that all the stars had the same composition, and that was taken seriously, but that hydrogen and helium were the most abundant elements in the universe. It took a long time for that to be accepted. You can think about multiple reasons for that. One is she used very new physics. 1925 quantum mechanics was not at all well established. She used quantum mechanics. She used very modern physics for the time. Another, of course, she was a graduate student. She was 25 at the time. She was born in 1900. And there was a third issue that also contributed very much, I think, to her work not being immediately accepted. Can you guess what it was? Louder. No, she's a woman, very definitely. She was not a shy, shrinking violet any more than I am. In her prime, she was 5'10" and very broad-shouldered. And when Harvard finally gave her her own professorship, she said, "I find myself cast in this curious role of the thin end of the wedge." But she was the one who showed that the universe is mostly hydrogen and helium. And this has enabled us to understand conditions in the very early universe, to interpret the microwave background, and lots of other things that tell us what the universe was like 13 million years ago. And that also was very much resisted because of who she was and where she came from. Can I tell you that story? Yeah. Oh, okay. She was in a girls' high school in London and sang with the chorus, and therefore she sang under Gustav Holst, the guy who wrote The Planets, right? Well-known composer. And therefore I know Gustav Holst at one remove, because I knew Cecilia quite well later in her life. This is a periodic table that is not from Mendeleev. This is from a chap named Crookes, who was a chemist. And I don't know whether you can see it or not. It doesn't show up very well on the face of the computer. But there's a column down the middle. It's just totally empty. And if you were putting everything together now, you would put in helium, neon, argon, krypton, and xenon. In some sense, Crookes predicted what we now call the noble gases, though he didn't realize it. But you get, how many of you have some vague memory of Bohr orbits in high school? There was it looks like a solar system. There's a nucleus in the middle and the electrons orbiting around. That wasn't how the chemists saw elements. That was how the chemists saw atoms. He's reinvented the wheel, only his is square. But if you're going to make a molecule, those are too complicated. There's a good one. If you're going to make a molecule, square atoms actually work rather well. It makes it quite easy for the atoms to share electrons. And so the chemist's picture, which was different from Bohr orbits, was not a foolish one, and in fact led to better quantum mechanical calculations than the physicists did. We have here some feminist blurs. The issue of women in science is a very old one, but there have always been a few. One of the ones that a few people at least have heard of, well, any of you who belong to the local amateur astronomy society will have heard of Carolyn Herschel, who was the sister of William Herschel, discoverer of Uranus. But she was allowed to work in science because she worked with her brother. Other women were allowed to work in science because they worked with husbands. If you think of the Curies first, I'm not sure that's the right answer for them, but Hevelius's wife worked with him, Huggins' wife. Oh yeah, this is the 150th anniversary of the recognition of emission lines, the demonstration that many of the fuzzy things in the sky are actually diffuse gas. They're not just clusters of stars, they're genuine diffuse gas. Huggins and his wife, Margaret, 1863. Again, I remember it well. Along with, of course, the Gettysburg Address and all that other stuff that happened in 1863. But Margaret Huggins got to work in astronomy because she worked with her husband. Carolyn Herschel worked with her brother. Father-daughter combinations happen sometimes as well. There's a fundamental idea of physics called Noether's theorem. I do not pronounce her name well. She has an umlaut. I don't do well in umlauts. But her idea was that wherever you have something that's conserved, like mass energy or angular momentum or ordinary linear momentum, there is associated with it some kind of coordinate transformation that doesn't affect the physics. This symmetry equals conservation is Noether's theorem, roughly. And she was allowed to be educated in mathematics and to a certain extent in physics because her father supported her. And there was a long period of time when really all the women who did science were able to do it because they had connections of a family of some sort. I think even now, outstanding, maybe not now, but okay, my generation, which is a long time ago, I turned 70 this year, a few days ago actually, which means I don't have to do jury duty anymore. Okay, I don't know what jury duty is like in Kentucky, but I know what it's like in California. Okay, even my generation, the women who became scientists virtually all had fathers, maybe an older brother, but typically fathers who did something quantitative. My father was a chemist. You could make a male scientist in one generation, but it took two generations to make a female scientist. I think that may still, to a certain extent, be true. It would be nice to do good statistics on this kind of thing. Okay, my two feminist blurs here, the applications of quantum mechanics to many electron systems. Hertha Spooner, who was Debye's student, Frank's wife, and perhaps somewhat better known, X-ray diffraction imaging of biologically important molecules. Dorothy Crowfoot Hodgkins, who got a Nobel Prize. She did insulin. And the one that has been in its day somewhat controversial, the X-ray imaging of the DNA molecules, done by Rosalind Franklin in London. And the people who understood the images and got the structure of DNA right almost, and got the Nobel Prize were, of course, Crick and Watson. Should Rosalind Franklin have shared that prize? She was dead by that time. They don't give Nobel Prizes to dead people. Am I still on it? It was her advisor who was the third person to share that prize. But there have been women involved in the sciences and in this critical issue of blurring boundaries and invading other territories. Some of my favorite quotes. How many of you have access to a copy of the Oxford English Dictionary? Everybody should. It's wonderful. You can learn all kinds of things from it. I mean, they think it's just a dictionary, but it's full of wonderful information. There's this chap quoted saying in 1900 that the boundary between chemistry and physics is almost invisible, and he thinks it's going to disappear completely. That is clearly not true. If you're a physicist or you're a chemist, you will know this. I belong to both the American Physical Society and the American Chemists Society. They are very different, I assure you. It is not true that the boundary of chemistry and physics has disappeared. They overlap a little bit in material science. That's a good quote, which turned out to be really wrong. What else do we have here? Yes, I said that my father deeply resented physics having grabbed atomic structure. J.H. Moore published in 1918 A History of Chemistry. And his last line is, the properties of the elements are periodic functions of their atomic numbers. That was the fundamental contribution from Moseley. But there is Moore thinking that is chemistry. 1935, the Ohio Journal of Science. Ohio is just across the river from here. Not quite here, but further west, right? Yes. East? Sorry. North. Well, I know it's north of here, but north just of here is Indiana, right? And next to that is Ohio. Okay. I said that the Trimbles went through Kentucky to Ohio across the Cumberland Gap and north. But they came back, grandfather Joseph Starling Trimble to marry Nellie Harrington. They came back across the river to Kentucky to get married. I shan't tell you why. You have to figure it out for yourself. But here we are with, yes, 1935, George Gamow in the Ohio Journal of Science. I don't know whether there was a Kentucky Journal of Science at that time or not. There may well have been. In any case, he says, shall we call it nuclear physics or shall we call it nuclear chemistry? They both exist, but they're very different. And another George Gamow line. George Gamow was a remarkable person, but he was not the one who predicted the microwave background. That was his students Alpha and Herman. But as late as 1961, Gamow was still trying to understand what was going on in laboratory physics. And he wrote to Ralph Alpher, whose son Victor has sent me a copy of the letter, saying he didn't understand how Weber could think he could see gravitational radiation with crystals. It said that there were deep, deep places in the interface between physics, astronomy, and chemistry that even George Gamow didn't understand. It's one of my favorite quotes. I always know the right thing to say after the right time to say it has passed. Modern blurring. Things that are physics and chemistry and astronomy together. The atmosphere of Titan, formation of molecules in interstellar material, laboratory analogs of the magnetic fields of the Earth and the Sun. The Sun's in the process of flipping its magnetic field upside down. It does that every 11 years. And so unless you think the world has come to an end every 11 years, it won't come to an end this time. There may be people who think the world does come to an end every 11 years. They're only 10 years old. But you can build laboratory simulations of the magnetic fields of the Earth and the Sun, maybe. All kinds of